Now that you learn to work with truth tables and honestly how much of a hassle lengthy truth tables can be, I'm going to show you the shortcut method. The shortcut method treats a sentence or an argument as a puzzle in which you're trying to come up with truth value assignments for the atomic sentences that demonstrate what properties that sentence or argument has. You can show a sentence is not logically true by coming up with a set of truth value assignments that makes the sentence false. You can show a sentence is not logically false by coming up with a set of truth value assignments that makes that sentence true. If you have two sets of truth value assignments, one that makes the sentence true and another that makes the sentence false, you show that the sentence is logically indeterminate. You can also use the shortcut method to prove that an argument is invalid by coming up with one assignment of truth values for all the atomic sentences involved that make the premises true and the conclusions false. This is finding the row of the truth table that demonstrates invalidity without having to construct that full table. Unfortunately, the shortcut method does have limitations. It's proving a sentence is logically true or is logically false requires a full truth table. Similarly, proving an argument is valid requires a full truth table. If it's actually not possible to come up with a shortened truth table that makes the premises of an argument true, or the premises of an argument true and the conclusion false, that does mean that the argument is valid. However, especially while you're new to using the shortcut method, I would be careful not to assume that just because the shortcut method isn't working for you, that the argument is valid. It might just mean you're missing something. So until you're really confident with your abilities with this, I recommend you double check your work by constructing a full truth table if you've come across an argument that you think is valid because you can't find the shortcut. Now that with the disclaimers out of the way, let's work some examples so that you can see the shortcut method in action. So first we're going to start with sentences and showing them not logically true or not logically false, or in the case of the examples that we're going to do here, both. So what we're going to do is we're going to make a shortened truth table. And what we're going to try to do is make this sentence true first. So we have a conditional. So what we know we need to do is make it such that that it's not the case that the antecedent is true and the consequent is false. The easiest way to do this is to just outright make the antecedent false. So our antecedent here is a disjunction. So what we're going to do is we're going to make that disjunction false by making P false and Q false. So once these two are false, that makes this disjunction here, the whole thing, false. And once you have a false antecedent, that makes this whole conditional true. So now we can assign anything we want to R. I'm going to pick making it false as well. So now we know because Q and P are both false, this disjunct is also going to be false. So we have a false antecedent and a false consequent, which again makes that whole conditional true. So now what we're going to do is we're going to do the same argument and we're going to try to make it false, because if we can do that, we can show that this sentence, not argument, is logically indeterminate. So we're going to do it again here. So now we need to make it false, which means we do need to make that antecedent true. So we're going to start by making it true, by making either P or Q true. So I'm going to pick making P true, which makes the disjunction true. So now we need to make the consequent false, right? Which we can do by making R. So we've made P true. Now we can make R false. Because if we make R false here, then it's false in both of these, so both of these conjunctions are false, which makes the disjunction here again false. So with a true antecedent and a false and a false consequent, we've got a false conditional overall. And now we can pick anything we want for Q. So the fact that we don't need Q to be one thing or the other here tells us that there's going to be more than one row of this truth table on which we're going to have this sentence being false. So I'm just going to pick making Q true. It doesn't affect the truth values of any of these of the sentence overall at all. But because we've shown that it's true, it can be true, and we've shown that it can be false, we've shown that this sentence is logically indeterminate. So let's do a couple more examples with sentences. Next we have A and B if and only if A or B. So this one could be done with a 4-row truth table. So it's not that much of a hassle, but let's try it with the shortcut method because then we don't have to do a truth table at all. So let's start by making the sentence true. So to do that, we have to make either both sides true or both sides false. If we pick making both sides true, then we just need to make A true and B true, which makes our conjunction here true. And then we have A true and B true, which also makes the disjunction true, right? Because it's inclusive, because we have an inclusive or. So now with both sides being true, we've made the biconditional itself true because those truth values match. So with that, we've shown this argument is not logically false. So now let's try making the sentence false. Let's do a separate set of truth value assignments for A and B. Now what we need to do here is make the truth values not match. And the way to do that with having a conjunction on one side and a disjunction on the other is to make either A or B false. So I'm going to pick making A false. So now A is false, which means this conjunction here is false. Because for a conjunction to be true, both conjuncts have to be true. And now we need to make A or B true. So because A is false, that means we have to make B true. And because we have one of our disjuncts true, we've made this true. And because we have mismatched truth values on a biconditional, we've made this false. So this sentence is also logically indeterminate. Let's do one more. So now we have J or H, and it's not the case that J and H. So this is our either or, but not both exclusive or. We already know that this is logically indeterminate because we did the truth table for this earlier. But let's just see how much easier it is to do this. How much easier these things are to do with the shortcut method. So let's start by making it true. So to make it true, we need both conjuncts to be true. So to make J or H true, one of the two needs to be true. So I'm going to make J true. J is true. So now this, let me write this on top, it'll be easier. Now that that's true, this disjunction here is true regardless of the truth value we give to H. So now the other conjunct is the negation of this sentence, the conjunction here. So we need this sentence to be false to make this negation true. So I'm going to make H, so I'm going to make H false. Since H is false, this conjunction here is false, which makes the negation true. And with a true disjunction and the true negation, that makes the conjunction that's our main connective true. So now let's make the sentence false to prove that it's logically indeterminate. We need to do truth value assignments for J and H again. And of course, there's more than one way to make this sentence true, and there's more than one way to make it false. Sometimes that's going to be the case. Sometimes it's going to be one particular thing that you're looking for to make the sentence do what you want. So what I'm going to do is I'm going to make the disjunction false. I want to make this false. So to do that, I need to make J false and H false. And now we have a false conjunct, which makes this false, even though it makes this negation true. So that's how you can show sentences are not logically true by showing that they can be false, or not logically false by showing that they can be true. And with all of these examples, if you do both, you show a sentence as logically indeterminate. So now let's move on and look at some arguments and doing the shortcut method with arguments. As I said at the beginning of this video, the goal with arguments is to find a set of truth values assignments for those atomic sentences that make the premises true and the conclusion false. For this argument, we've got 4 atomic sentences. If you had to do a truth table for this, it would be a 16-row truth table. That is a massive pain, so the shortcut method is really helpful here. So we want to start by making our conclusion false. And to do that, we just need to make S false. So now that we have a false conclusion, we need to make both of our premises true. So we need to make this premise true, which we can do by making either P or Q true. I'm going to make P true, which makes this premise true. So now we need to make the first premise true, and we have to be careful because we already have a true antecedent, because the antecedent is the same as our second premise. So what we need to do here is we need to make that consequent true as well, so that we can have that first premise being true as a material conditional. And the way to do that is to make the making the consequent true. We already know S is false, so R has to be true to make this disjunction true. And then once we have a true antecedent and a true consequent, so this premise is also true. So now just to complete the truth value assignments, we need to pick something for Q. I'm going to pick making Q true as well. But this just shows that we also could have done true, false, true, false. So that says there's 2 rows if you were to do the full truth table that show this argument is invalid, at least those 2 rows. So that's the shortcut method that shows that this argument is invalid. So let's do the next one. Here we have the argument with the premises, if P or Q, then R. And our second premise, it's not the case that Q. With the conclusion, it's not the case that R or P. So let's lay out our shortened truth table to do our assignments. We've got 3 atomic sentences, P, Q, and R. And we want to start by making that conclusion false. To make a disjunction false, both disjuncts have to be false. So we need to start by making R true, because if R is true, then this negation is false. And then to make the disjunction false, again, P also has to be false. And that makes this sentence overall false. So now we need to make our premises true. We need to make not Q true. So we need to make Q false. If Q is false, then the negation of Q is true. So now we've actually already assigned truth values to all three of our atomic sentences. So let's make sure that makes our first premise true. So we've got a false antecedent and a true consequent, which again, material conditionals are only false if the antecedent is true and the consequent is false. So this is a true conditional. So now we have the truth value, the truth value assignments for those atomic sentences that show that this argument is also invalid. This is our shortened truth table that shows this. And when you submit work, I would recommend you have the argument written out and then your truth values written like this. So it's really clear to us what you did and how you got to the judgment you made that the argument is invalid. Having this written out is very similar to the way that you would highlight or circle that, that line of the full truth table that shows the argument is invalid. So let's just do one more example and then we'll wrap up this video. So here we have if A and B, then B and C, and the second premise, B and C, with the conclusion being A. So we've got three atomic sentences, A, B, and C. And we're going to start by making that conclusion false. So our conclusion is just A, so we're going to make A false. And now we need to make our premises true. So we're going to make B true and C true to make this conjunction here true. So now let's look and make sure this works with our first premise. B and C are true. That consequent is our first premise, so we've got a true consequent, which we already know means we have a true conditional, because conditionals are only false when we have a true antecedent and a false consequent. So the fact that we have a true consequent means we're going to have a true conditional here. So we also have a false antecedent because A is false. So one of our conjunctions there is false. So false antecedent, true consequent, that's still a true conditional. So here we've got that row of the truth table on which A is false, B is true, and C is true that shows that this argument is also invalid. Now, for the sake of this video, I picked arguments that were invalid and I picked sentences that were indeterminate because I wanted to show you the success of using the shortcut method. It's not always going to be successful. Sometimes you might have a valid argument that you're trying to show is invalid. And if you can't succeed in using the shortcut method, as I said earlier, that can mean that the argument is valid, but it could also mean, especially while you're new at this, that you're missing something. So definitely still use those full truth tables when you need them, but this is really helpful to not have to do that when you can puzzle it backwards and kind of reverse engineer finding those shortened truth tables to show that an argument is invalid or show that a sentence is not logically true or not logically false. So just because we're not on PowerPoint doesn't mean I don't have recommended readings for you. These pages in the logic book specifically is where they introduce using the shortened truth tables for doing logical truth value of sentences and doing invalidity and arguments. And of course, this, as well as most of what we've covered already, is in the third lesson in the course manual. And then I have some recommended practice problems for you here. That's page 85, 2A, page 86, 4E, and then page 103, 2A and 2C. Those first two problems are doing sentences and showing they're not logically true or not logically false. And then those last two are with argo Definitely look at those, see if you can make it work, and then check out the video that I'm going to post going through those problems if you have any questions or just want to see how they're done after you've tried them.